So I hope you get some idea from the PowerPoint slide just now, and let's do this again. One carbon atom. Okay, I'll just draw one only. It has a relative atomic mass of 12. 1 mole of substance, or you can call it 1 mole of carbon atoms. 1 mole of carbon atoms would have 6.02 times 10 power of 23. I'll just call it pieces because here is considered one piece. So 6.02 times 10 power 23 pieces of carbon atoms. Okay, so if I have the ability, which I do not have, to draw 6.02 times 10 power 23 amount of atoms, just imagine this graphic represents so many of such atoms, and I put it on the weighing scales. It would have exactly 12 grams. So it would weigh 12 grams. Alright, so this is what we call a molar mass. So the next thing is, I would like you to look closely at this formula. This formula is useful in the sense that we already know that 1 mole is like 1 doesn't have 12 units. So 1 mole has Avogadro's unit. 2 mole is just simply 2 times Na. Alright, or 3.7 mole, you just simply use 3.7 times 6.02 times 10 power 23. Okay, so nevertheless, let's go through it. Is this representing the actual number of entity? Okay, this entity could be atoms or molecule. This one is the number of mole, and this is Avogadro's number, constant. Okay, it will always be given as 6.02 times 10 power 23. Alright, so now we also need to see the fact about actual over standard. As I mentioned before, actual number over standard number. You can also relate with the actual mass over standard mass. With such interconnection, I'd like to invite you to do one calculation. Calculate the number of atoms of 28 gram of Fe iron. Okay, Fe is given as relative atomic mass of 56. Alright, the Avogadro's number is also 6.02 times 10 power 23 per mole. Alright, so let's use a blue pen to write down the crucial information. This one is the actual mass, and this one is the molar mass, and this one is the Na. So we can find this by putting them together, rearranging the formula. You will be able to get this. So this is 28 over 56 times 6.02 times 10 power 23. This seems like giving you the final answer of 3.01 times 10 power 23. Alright, I hope you can see the interconnection. Okay, perhaps we can try a new page to see things clearer. Again, this one is the same as this. Alright, so n over 6.02 times 10 power 23, and then this actual mass 28 grams. This one is 56. 1, 2. So N is half of the 6.02 times 10 power 23. That's why you get 3.01 times 10 power 23. Now, I want you to look at another concept. How many molecules? That's number one. How many atoms? Alright? So how many of this stuff are there in 1.23 mole of CO2? You see, CO2 is like having three types of atom, but we combine them together. We call them one molecule. Alright? It's like one set. But how many atoms are there? 3 atoms inside. So, depending on the question, let's answer the first question. First question, they want number of molecules. Meaning how many sets? How many sets are there in 1.23 mole? So 1.23 times the Avogadro's constant. Number 2, it is more concerned about total atoms, so we also need to put 3, then only we times the mole, then times the Na. For atoms, it is important to know how many atoms are there inside the molecule. So we need to times 3. Question number 1 seems to be more interested in finding how many sets. So I put a key question here. How many sets? This one is how many atoms all together. Alright? How many atoms all together? So pay attention to this and you will learn something new.